Welcome to the Subskills video for chapters 7 and 8 in trigonometry. We will be solving quadratic equations using the method of completing the square. In addition, we will be given equations of circles in general form and complete the square to get the equation in standard form, which will allow us to graph the circle. So let's go ahead and get started. We are trying to complete the square of the equation x squared minus 6x minus 8 equals 0. So a little bit of background. I'll go ahead and do a quick background piece, which is if I have something like an a minus, or actually I'm going to write an x minus a squared. Okay, well, I could write that out as x minus a times another x minus a. Or if I then multiply that out, I get x squared minus ax minus another ax, and then plus an a squared. And so we have it x squared minus 2ax. We have like terms, and so they combine, plus a squared. And so what the goal is going to be for completing this square is to try and write a polynomial in this perfect square trinomial so that we can rewrite it as a binomial squared. So the process. First thing we're going to do is we're going to isolate the x squared plus bx term. And then we're going to basically make that third term exactly what we want it. So I'm going to go ahead and do this in practice. So the first thing we want to do is we want to isolate this x squared minus 6x. So I'm going to go ahead and add 8 to both sides, and I'll leave some space. So I get x squared minus 6x. I'm leaving some space, and then I'll write equals 8. Now, the reason why I'm leaving some space in that third term on the left is because I want to put a number there that will serve me well. So let's take a look. What I'm trying to figure out what term, I want this a squared, but the problem is that there's a 2a here. So the 6 is actually twice as big as I need it to be. So I'm going to divide that 6 by 2, and I get -3. And then I will square it. Anytime you square anything, you get a positive. So now I'm going to add 9 to both sides. And so now I have x squared minus 6x plus 9 equals 17. Now, on the left of the equal sign, this is a perfect square trinomial. I have my x squared on the first term, and a squared, that's a 3 squared, in the last term, and I have that 2ax in the middle. So now I can go ahead and write that as a perfect square trinomial, and what goes in with the square is simply, it's going to be x, and then I bring that -3 down. So it's x minus 3, and that equals 17. And now we are able to use the square root property, and oftentimes it's written where you square root both sides. And don't forget the plus or minus whenever we take the square root of both sides of an equation, and we come up with x minus 3 will equal plus or minus square root 17. And now we are almost solved for x all the way, but we just have to add that 3 over. And notice the 3 is a whole number, and the rad 17 is not. And since the 17 is under the square root, we cannot combine those terms. So we just get 3 plus or minus rad 17. So in essence, we got two solutions, 3 plus rad 17, or x could be 3 minus rad 17. And that's it. All right. And this is just an alternative to using the quadratic formula. And so where the completing the square is very helpful is for it is to, or I'm sorry, where completing the square is helpful is also rewriting our conics. Also for solving equations like this, it's nice if the B term is even. So if it's not even, this process is not ideal, but sometimes we have to do it anyways, but it's definitely a nice option if that B is even. All right, so again, we're going to first try and isolate the x squared plus bx. So again, in this case, I'm going to move that c term over. So I'm going to subtract the 8 over 3x squared plus 24x, leave some space, equals -12. And I only want an x squared when possible. So because I have an equation, I can divide everything by that a, or in this case, 3. So because I have an equation, I can divide both sides by 3, which means I divide each and every term by 3. And now I have x squared plus 8x, leave a space, and that will equal -4. So again, this is a nice, or completing the square is a nice option because that 8 is even. So let's go for it. So we divide 8 by 2 and we get 4. I like to circle that, square it, and then we will add 16 to both sides. Now we're ready to write that as a perfect square. So that's going to be x plus 4 quantity squared. And then we get -4 plus 16 is +12. Now we're ready to use that square root property. And we get x plus 4 equals plus or minus rad 12. We can simplify rad 12 because rad 12 can be written as rad 4 rad 3 or 2 rad 3. Because the square root of 4 is just the whole number 2. And so we get x plus 4 equals plus or minus 2 rad 3. Again, I will now subtract the 4 over, but we cannot combine the 4 and the 2 because the 2 is just the coefficient in front of the square root of 3. So we get -4 plus or minus 2 rad 3. Okay, so that is a couple examples of completing the square to solve quadratic equations. It does get more involved if your B term ends up being either an odd or a fraction, but in that case, you're also welcome to use the quadratic formula. Let's go ahead now and try and get our equation of a circle into standard form. So recall the standard equation of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared, where r is the radius and the center is at the point hk. So essentially what we need to do is we need to complete the square for x and y separately. So the first step, here, let me move that up. Okay, here we go. All right, so the first step is always to reorder where we want our x squareds and our x's together with a space. we want our y squareds and our y term together, and we want to move our constant to the other side. Again, I'll leave a little space and have that equal 3 after adding 3 to both sides. And now we're going to go ahead and complete the square separately for x, and we'll complete the square separately for y. So just looking here, I have an x squared and an x term. So again, I'm going to divide that -6 by 2, that's -3, and square it. And that's what I will add to both sides. I will add 3 squared, or 9, to both sides. Same thing over on the y's. I will divide the 4 by 2 and to get 2, square it, and then I will add 4 to both sides. So that will get me to that x minus 3 quantity squared plus y plus 2 quantity squared equals, and then I just add all of that up. So 3 plus 9 plus 4 gives me 16. So now I'm ready to figure out, well, what's the center? So the center, the x value of the center, comes from the number that's being added or subtracted in with the x. So that's going to be 3, but it's the opposite sign. And that's really because the equation has x minus h, that's always going to be the opposite sign for both h and k. So the y value of the center will be the number that's being added or subtracted in with the y. And since there's a +2, the opposite sign will be a -2. So the center of this circle will be at the point 3, -2. Now we have r squared is 16. So that means r is ±4. But since the radius is a distance, it's going to be a +4. And now we're ready to go from the center. We'll go up 4 units, down 4 units, a little off the graph, left 4 units, and right 4 units. And now we're ready to sketch that circle. Oops. There we go. Okay. And again, we plotted the circle, the center of the circle, and then from the center, we went up, down, left, and right 4 units since the radius was 4. And now we will go ahead and complete the square again on x and y and try and graph the circle. So here, again, first step is just reordering. So I'll subtract that 13 over and make sure that my x squareds are with the x and the y squareds are with the y. And now we'll complete the square on x. So divide the 2 by 2 to get 1, square it. We will add 1 to both sides. Same thing, we'll divide -8 by 2 to get -4, square it. Add 16 to both sides. Now we have 2 perfect square trinomials. And so we're just ready to rewrite them as a binomial squared. So the first will be x plus 1 squared, and the second y minus 4 squared. And then -13 plus 1 plus 16 gives us +4. So the center will be at the point -1, 4. Again, the x value will give us that x value for the center, but the opposite sign. The y value, or I'm sorry, let me say that again. The number being added or subtracted to x will give us the x value of the center, but the opposite sign. The number added or subtracted to the y will give us the y value of the center, but opposite sign. So that gives us that center, -1, +4. Next, the radius. Well, we know that the 4 is the r squared. So now we can, again, take the square root of both sides, but it will be a positive. Square root of 4 is 2. So my center is over at -1, +4. And now I will go all 4 directions, 2 units. So 2 up, 2 to the left, 2 down, and 2 to the right. And then just connect the dots and draw that circle. Let's try that again. There we go. And that does it. So we are all set. And this will help us being able to handle polar coordinates or really polar equations when we get there in trigonometry.